students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So we are done with the PU2 syllabus. Now we will be doing mock test section wise. So today's mock test, as it is Sunday, and today will be KPL 8, where we have given you questions from the entire physical chemistry of PU2, which included 3 chapters, that is your solutions, electrochemistry and chemical kinetics. Okay, so now I'll be discussing the solutions of these questions, and what is your task? You need to check these answers, you need to give marks to yourself, and you need to post your scores in the comment section. Okay, so now let's get started without any further delay. So the first question here is, solubility of gas in a liquid increases with. Okay, so solubility of gas in a liquid. Okay, so here there are 2 factors, pressure and temperature, right? If you increase the pressure, solubility will increase, and if you decrease the temperature, solubility will increase. Okay, so sorry, one second. Pressure you have to increase. Okay, and if you decrease the temperature, solubility will increase. Now a very common example of solubility and temperature, of like the relation between temperature and solubility of gas in a liquid, is your cold drinks, right? You can see when the cold drinks are very chilled, okay, at that time that gas, carbon dioxide gas, can be felt while drinking in the carbonated drinks. But once you have left the bottles for 3 to 4 days and the temperature has become very warm and the cold drinks is like not chilled, in that case you can find less amount of carbon dioxide. This is because when the temperature increases, the solubility of the gas decreases, right? So we need high pressure and low temperature. So let's see which is the correct answer. Increase of pressure, so this can be answer. Decrease of pressure, no. Increase of pressure, decrease of pressure, no. And we need decrease in temperature, so this is also no. So the correct answer for this question will be option number A. Okay, next, Henry's law constant for the solubility of N2 gas in water at 298 Kelvin is 1 into 10 to the power of 5 atm. Okay, Henry's law constant is given to us, that is 10 to the power of 5 atm. Okay, next, the mole fraction of N2 in air is 0.8. This is very important, mole fraction of N2, okay, but this is in air, is 0.8. The number of moles of N2 from air dissolved in 10 moles of water at 298 Kelvin and 5 atm pressure is. So what is the number of moles of water? That is 10 moles. Okay, and here pressure is 5 atm. Okay, so now question you can imagine like this. Suppose here we have water, okay, 10 moles are there, 1 2 3 4 5 6 7 8 9 10, and here N2 molecules are there. How many? Mole fraction of N2 in the air. Okay, this is air, suppose I am doing like this, and this mole fraction is 0.8. okay, now what the Henry's law says, that the amount of solute or the moles of or the solubility of gas in a liquid depends upon its partial pressure of the liquid. Means how much N2 will be soluble in this one is decided or depends on the partial pressure of N2 above the solution. Okay, so solubility depends, according to Henry's law we can say, solubility depends on the partial pressure of the gas above the liquid. Okay, partial pressure of the gas above the liquid. Okay, so now what is there? We have like if you see when you give like this 5 atm which is given, that is not the partial pressure of N2, that is the total pressure in the atmosphere, right? So from here we need to calculate first the partial pressure of N2. How to calculate? Partial pressure of N2 will be mole fraction of N2 into the total pressure. What is the mole fraction of N2 in the air? 0.8. What is the total pressure? 5. So I'll get 4 atm. Okay, 4 atm is what? 4 atm is the partial pressure of nitrogen gas. Now we can use this calculation that is Henry's law, P of N2 is equal to KH into mole fraction of N2. Okay, solubility. So I can write P of N2 is equal to KH into number of moles of N2 divided by number of moles of water. And you know, in mole fraction calculation, here we can eliminate or we can ignore the number of moles of N2 because this is very less as compared to the moles of the solvent. So now if I calculate, this is 4, okay, this is 10 to the power of 5, this I need to calculate, and number of moles of water is 10. So if I solve this N2, that is I will be getting 4 into 10 to the power of minus 4. Okay, so correct answer here will be option number A. Okay, fine. Next question, choose the correct statement. Okay, so yeah, KH value is same for any gas in any solution. No, KH value is dependent on the solvent. Okay, it is different for different gases. Higher the KH value, more is the solubility. Let us check this one. If you see, P of the gas is equal to KH into mole fraction of the gas, and mole fraction is nothing but solubility. The solubility is represented in terms of mole fraction. So I can say that P of the gas by KH is equal to mole fraction of the gas, right? So what I can say that KH and the solubility are inversely proportional to each other, right? So if KH value increases, higher the value of KH, more is the solubility of the gas. This is a false statement. This is also false statement. KH value increases on increasing the temperature of the solution. Now first of all, see, if I increase the temperature, then what will happen to solubility? Just now we discussed that if temperature increases, solubility decreases. Solubility will decrease. If solubility decreases, then KH will increase or not, because they are inversely proportional. So I can say that if I increase the temperature, KH is also increasing. So this is a correct statement. Next, easily liquefiable gases usually have lesser KH value. This is also correct statement. So here the correct answer will be both C and D. If you have marked any one of this, you can assign 1 mark to you. Okay. Next question, a non-volatile solute A tetramerizes in water. Okay, tetramerizes in water to the extent of 80%. 2.5 gram of A in 100 gram of water lowers the freezing point by 0.3 degrees Celsius. Molar mass of A is how much? Okay, so first of all, what is alpha value? 0.8, right? 80%. And what is the mass of the solvent? 2.5 gram. Okay, next we have mass of the solute. 2.5 gram is the mass of the solute. Mass of the solvent is 100 gram. Next we need to calculate delta TF is also given to you, 0.3. Then we need to calculate KF. KF value is 1.86. Okay, this is done. So now what I need to calculate? We need to calculate the value of molar mass of the solute, right? For that, first of all, we need this formula, delta TF is equal to I into KF into M. Now what is I here? Van 't Hoff factor, right? Now we need to calculate this I value from the alpha value. So what is the formula for alpha? I minus 1 by 1 by N minus 1, right? So now 0.8 I minus 1 by 1 by 4 minus 1, because it is tetramerizing. So what will I get here? 0.8 is equal to 3 by 4, right? So it will become 4 by 3 into 1 minus I. Okay, so now if you solve this, we will get 3 8s are 24. Okay, and then I'll get 4 minus 4I. So now if I solve this, we'll get, let me check the calculation once. We'll get 4 minus 4I, yeah, fine. So now if I take this is 4 minus 2.4, okay, so I'll get 1.6, I think, yeah. So now I will be equal to 0.4. I value we got 0.4. Now what is delta TF value? Delta TF is 0.3, right? Delta TF is 0.3. I value is 0.4, okay. Then KF value is 1.86. Okay, molality, W2 is how much? 2.5. W1 we need to, M1 we need to calculate, M2 we need to calculate into 1000, okay, by W1, that is 100. Okay, so now if I solve this and calculate the molecular mass, I will be getting around 62. Okay, so the correct answer for this question will be option number A here. Fine. Next question, the KH value of argon, carbon dioxide, formaldehyde and methane are respectively, these values are given. The increasing order of solubility of gas in liquid is, okay. So now if you see, we have this formula like P of the gas is equal to KH into mole fraction of the gas, right? So I can say that P of the gas by KH is equal to mole fraction of the gas. So this is what? Inversely proportional. Whichever KH value will be least, it will be more soluble, right? So now if you see here, we have first one 40.3, which is the least one. This is the least one, right? And this is for formaldehyde. So formaldehyde will be the highest soluble gas. So we have two options, we can eliminate these two. Now you can find the next one after this one, which is the least value, 4.13, that is 4. So we will get this one. Correct answer will be option number A here. Next, the vapor pressure of pure liquid A and B are 450 and 700 mm of Sg. If the total vapor pressure of the mixture is 600, then what is the composition? Okay, so this is also from the Raoult's law, right? Question is from which topic? Raoult's law. Okay, Raoult's law. So what's the formula for Raoult's law? P total is equal to P naught A into XA plus P naught B into XB. Now in terms, the XB can also be written like 1 minus XA. Okay. Now if I substitute, what is the total pressure? Total pressure is 600. Okay. P naught A is how much? 450 into XA. Then what is P naught B? P naught B is 700 into 1 minus XA. Okay. Now if you solve this and calculate, you will be getting XA as 0.4. Okay. And what is XB? XB will be 0.6. Okay. So correct answer here will be option number A. Okay. Next, a mixture of phenol and aniline shows negative deviation from Raoult's law. This is due to the formation of. So negative deviation means the interaction between phenol and aniline has increased, right? Now this is due to the formation of intermolecular hydrogen bonding. Okay, so option number C. Next, solution A contains acetone dissolved in chloroform. So solution A has what? Acetone, okay, dissolved in chloroform. And solution B contains acetone dissolved in carbon disulfide. So acetone dissolved in carbon disulfide. The type of deviation from Raoult's law shown by solution A and B are respectively. So if you see this one here, there will be force of attraction will increase. So this one will show negative deviation. This one will show positive deviation. So correct answer here will be option number D. Okay. Next question, relative lowering of vapor pressure of a dilute solution of glucose dissolved in 1 kg of water is 0.002. The molality of the solution is, okay, this question is important. Okay, question is asked about molality. Okay, so for this you should know one particular formula, that is relation between mole fraction and molality. Okay, so here I want to write a formula. See, okay, molality is equal to mole fraction of solute by mole fraction of solvent into molar mass of solvent into 1000. Okay, clear? This formula you need to remember. Now let us see the question. Relative lowering of vapor pressure of a solute of a dilute solution of glucose dissolved in 1 kg of water is 0.002. So I can say relative lowering of vapor pressure is this much. This is the formula, right? So relative lowering of vapor pressure is 0.002, right? That means I got the value of XB here. Can I not get XA from here? XA will be 0.998, right? So now can we, and dilute solution means it is a solution of water, 1 kg of water. So I have molar mass of water also, that is 18 gram per mole. Now let us substitute quickly. What is XB? XB is 0.002, XA is 0.998 into 10 to the power of 3000. What is MA value? That is molar mass. Molar mass value is 18. Okay. Now if you solve this, we'll be getting around 0.111. So correct answer here will be option number C. Okay. Next, vapor pressure of a solution containing 18 gram of glucose and 178.2 gram of water at 100 degrees Celsius is. The vapor pressure of pure water is given to you. So this is again relative lowering of vapor pressure formula, right? See, this question, if you see, I'll be telling you first how to solve with formula. All the datas will write down first. 18 gram of glucose. So W2 is how much? 18 gram. Okay. 178 gram of water. W1 is 178.2 grams. Okay. Now what is the molar mass? M2. Molar mass of glucose is 180, right? And then molar mass of solvent, that is water, is 80. Okay. And the vapor pressure of pure water, P0 value is 760. Okay. So now I want to calculate number of moles of glucose. Okay, number of moles of glucose will be given mass by molar mass. So 18 by 180, that will be 0.1. Okay. Next, number of moles of, I have glucose and then water. Okay, number of moles of water will be what? Given mass by molar mass. So 178.2 divided by 18. Okay. So we'll get these two number of moles. Next we need to calculate the mole fraction of glucose. So that will be equal to what? Number of moles of glucose by the number of moles of water. So 172.8 divided by 18. So I can write 18 by 1728. Okay. Next, okay, now we got mole fraction of glucose. Now I need to calculate the vapor pressure of the solution, right? So I have this formula, delta P by P0, that is P0 minus P by P0 is equal to XB, right? What is the value of P0? P0 value is 760, right? Minus P divided by 760 is equal to X2 value, 18 by 1728. Okay. Now if I solve this, I'll be getting P value is around 752.4. Okay. Now how to solve this question within seconds? Okay. How to just see the options and take the correct answer. Now see, whenever we add a solute to the solution, okay, to a solvent, the vapor pressure always decreases. So the pure water vapor pressure was 760. Now if you add any solute to that, the vapor pressure will further decrease, right? So definitely it cannot be this one, okay, because it is more than 760. Now one more thing, when you add a solute, the vapor pressure decreases to a certain extent, like very minimal change is there, okay. So but if you see here, it has decreased a lot and here also decreased a lot. So this also cannot be the answer. The correct answer has to be option number B here, okay. Next question, spontaneity of a cell. So spontaneity of a cell means we need delta G should be negative. So correct answer here will be option number B. Next, for a cell involving 2 electron changes, okay, E0 cell is given to you. The equilibrium constant of the reaction. Okay, so let us write down the values first. E0 of the cell is given, that is 0.3 volt. 2 electron changes, so N is equal to 2. Okay, now we need to find the value. So we have this formula, E0 of the cell is equal to 0.059 by N log of K. Okay, now what is E0 cell value? That is 0.3. Okay, and here it is 0.06. I'll write for easy calculation, log K, right? Now this is 0.03. Now if I solve this, I'll get 10 is equal to log of K. Okay, now K will be equal to 10 to the power of 10. So the correct answer here will be option number D. Okay. Yeah, next question. 1 liter of solution of MgCl2 is electrolyzed completely by passing a current of 1 ampere for 16 minutes 5 seconds. The original concentration of MgCl2 is. Okay, so this question is also a little bit tricky here. First of all, we need to calculate how much gram of magnesium deposited, right? Complete electrolysis happened, means how much magnesium got deposited, same amount of magnesium will be present in the solution. So we can first calculate mass of magnesium deposited. For that, what are the informations given? Let us first note down. Okay, so we have first of all current is 1 ampere, time is 16 minutes 5 seconds, means 965 seconds. Okay, then yeah, and we have magnesium molar mass. So now we can use this formula, M is equal to ZIT under Z molar mass by N into 96500 into I into T, right? So what is the molar mass? Here it is 24, 2 into 96500. Current is how much ampere? 1 ampere, and we have 965 seconds. Okay, so here if I solve, I'll be getting 0.12 grams. Okay, now if I want to calculate the concentration, right, what is the concentration of MgCl2? So concentration means molarity, so number of moles by the volume of the solution. So if I see number of the moles will be 0.12 by 24, it is number of moles divided by volume of the solution is 1 liter, right? So if I solve this, how much I'll get? 1 by 2 into 10 to the power of minus 2. So that is 0.5 into 10 to the power of minus 2. I can write it as 5 into 10 to the power of minus 3. So correct answer here will be option number A. Okay. Next question. Charge required for the reduction of 1 mole of MnO4 minus to MnO2. So if you see, MnO4 minus is plus 7 and we have MnO2 is plus 4, right? So here to here we require how much? 3 Faraday. So correct answer will be option number B. Next, a current of 3 ampere is passed through a molten calcium salt for 1 hour 47 minutes and 13 seconds. Mass of calcium deposited. This is also very simple question. You have to just use M is equal to ZIT. So what is the value of Z here? 40 by 2 into 96500. Okay, then you have current is 3 amperes. Time you need to calculate. 1 hour is how much? 3600 seconds. 47 minutes means what? 47 into 60 seconds. So 6 sevens are 42, 6 fours are 24, plus 4 28, 2820, right? Then we have 13 seconds here, right? So I'll get 6433 seconds. Okay, 6433. Now if I solve this, I'll be getting around 4 grams. Okay, correct answer will be option number D here. Next, in a dry cell which is an electrolyte, so ammonium chloride is used as electrolyte, option number C. Next, which have the same pair, A has the value of A in the equation, this one is same for which pair? So see, suppose we have an electrolyte AB and we have an electrolyte XY. Okay, if the charge of the cations, okay, the charge of the cation and the charge of the anions are matching, like for example, if this is plus 1, this has to be plus 1, if this is plus 2, this has to be plus 2, if this is minus 2, this is anion, right? Yeah. Okay, so now suppose this is minus 2, this has to be minus 2. So if any pair of electrolytes whose cations charges are same and anions charges are same, they have same value of A. Okay, now if you see in the first one, okay, let us do now example first option in NaCl. Okay, NaCl and CaCl2. So if you see, Na has plus 1 charge, calcium has plus 2 charge, right? So the cation charges are not matching, this cannot be the answer. Now if you see this one, we have CaCl2 and MgSO4. So calcium has plus 2, magnesium has plus 2. Okay, cations charges matching. What about anions? This is minus 1, this is minus 2. Their charges are not matching, so this also cannot be the answer. Now if you see option number C, we have NaCl and we have KBr, right? So here also plus 1, here also plus 1, here minus 1, here minus 1, right? Cation charges are also matching, anion charges are also matching. So the correct answer here will be option number C. Okay. Next question. A secondary cell is one in which? So in secondary cell what happens? It can be recharged by passing the current through opposite direction. Option number C. Okay. Next, while charging the lead storage battery, while charging, okay, so in charging what happens? Reaction reverses, right? So at anode what will take place? Generally at anode oxidation takes place, and at cathode reduction takes place while discharging. But while recharging, anode will have what? Reduction, okay, and cathode will have oxidation. Okay, so at anode there will be reduction, so at cathode there will be oxidation. Here it is given cathode may reduction, so eliminate. Anode oxidation, eliminate. Anode reduction, yes, anode is reduction. Cathode oxidation, these two can be there. Okay, now read the other part of the statement. PbSO4 on anode is reduced to Pb. So what is the PbSO4 plus 2 to 0? So PbSO4 on anode is reduced to Pb. Okay, correct statement. Now if you see PbSO4 again plus 2 on cathode is oxidized to Pb. Is it oxidation plus 2 to 0? It is again reduction. So that is why this is wrong. So answer has to be option number C here. Okay. Next, the molar conductivity is maximum for the solution of concentration. So if you see what is molar conductivity formula, kappa into 1000, right, by C. So I can say molar conductivity is inversely proportional to concentration. That means if concentration increases, molar conductivity decreases. If concentration decreases, molar conductivity increases. So we need what? Molar conductivity is maximum. We need maximum molar conductivity, right? So that means the concentration should be very less. So concentration is less in this option. So that is why it is option number B. Next, for a chemical reaction, the rate law is given. If the concentration of A is double, the reaction rate will be. So this is very simple question. You have R is equal to Ka square, right? Now if the concentration is doubled, means it has become 2A. Then what will become? It will become 4AK square, right? This is R dash. So what is the relation between R dash by R? So that is again 4 times. So the new rate is 4 times the initial rate. Okay. So correct answer here will be option number B. Okay. Next, for a reaction A plus 2B give products when concentration of B alone is increased. Okay. Half-life remains the same. Means what? If the B concentration is increased, T half remains same. That is what is saying. Next, if the concentration of A alone is doubled, means you have concentration of A is increased, then rate remains same. Rate is same. Okay. Okay. The unit of rate constant of the reaction is. Okay. First of all, if we just find A plus 2B, I can write R is equal to K into A to the power of X and B to the power of Y. Right. This will be the rate law. General rate law for any reaction. Okay. Now what is said about A? If you increase A, rate remains same. Means there is no effect of concentration on the rate. Even if you change the concentration, rate is still remaining the same. Rate remains same. So this happens for which order reaction? For zeroth order reaction. If you see zeroth order reaction, okay, any suppose zeroth order reaction, that means what? If you change the concentration, rate is unaffected with that. So that means I can say X will be equal to 0. Next, if concentration of B is increased, half-life remains same. So half-life of first order, if you remember, is independent of concentration. T half for first order. T half for first order is 0.693 by K. Means for first order reactions, even if you change the concentration, the half-life remains the same. Right? So that means I can say that Y will be equal to 1. So if I write now rate law, I'll get K, A to the power of 0 will be 1. So I'll get KAB. So this is which order reaction? First order reaction. What is the unit of K for first order reaction? Second inverse. So correct answer will be option number A here. Next question. If the rate constant for a first order reaction is K, the time required for the completion of 99% of the reaction is given by. Okay, so again this is first order integrated law we need, right? So integrated rate law for first order. What is the formula? K is equal to 2.303 by T log of A naught by A, right? Now whenever question is in percentage, okay, always try to take A naught with 100, okay, A naught should be 100%. So if 99% is completed, then how much percent will remain? 1% will remain. So I need to calculate T for 99%. So 2.303 by K log of 100 means I can write 10 to the power of 2 by 1. So this 2 can be written here. So 2.303 by K into 2 log 10. Log 10 value is 1 and this one if I multiply, I'll get 4.606 by K. Okay, so correct answer here will be option number A. Okay, fine. Next question, this is again very important question. A gas gives you P, Q and R. Follows the first order kinetics with a half-life of 69.3 seconds at 500 degree Celsius. Okay, so what is the T half value given here? 69.3 seconds. Okay. Starting from the gas A enclosed in a container at 500 degrees Celsius and at pressure of 0.4 atm. So what is the pressure initially? So let us write like this. A gives you P plus Q plus R, okay, and A is 0.4 atm. Okay, the total pressure of the system after 230 seconds. Total pressure of the system P total, okay, after 230 seconds you need to calculate. Okay, now if you see T half value is given, from the T half value what can we find out? We can find the rate constant. So I can find that K is equal to 0.693 by T half is 69.3. okay, so that is 10 to the power of minus 2, right? 10 to the power of minus 2. So now what happens? See, this is 0, this is 0, this is 0. Now for example, T is equal to 0. At T is equal to 230 seconds, okay, some amount of A will react, right? This will form like this. Some amount of PQR will form. What is the total pressure at this step? If you add this all, we will get 0.4 plus 2x, right? That is the total pressure. Now if I want to see this calculation for first order reaction, I can write K is equal to 2.303 by T. T is 230. So for easy calculation, I will consider only 2.30, okay, not 2.303, 2.30 into log of P naught by P. What is the initial pressure? 0.4. What is the final pressure of A? 0.4 minus x, right? Now I need to solve this, okay, and K value I have already calculated, 10 to the power of minus 2, right? I will substitute that. K value is 10 to the power of minus 2. Now if you solve this one also, I will get 10 to the power of 10 to the minus 2. So I will get 10 is equal to 0.4 by 0.4 minus x, and if then I substitute this, I will get 4 minus 10x is equal to 0.4. So I will get x is equal to 0.36. okay, so now what I can say, 0.36 is x value. Now if I solve this one, so 2 into 0.36, 0.36 into 2, I'll get 0.72, then 0.72 plus 0.4, so this is 0.72. Now if I add, I'll get 1.12. Correct answer will be, sorry, option number D, okay, 1.12. okay. Now next question, our first order reaction is half completed in 45 minutes, okay, half completed in 45 minutes means T half is 45 minutes. Now 99.9%. Okay, now what is there? For this, solving this question, you need to know a very important formula, that is T 99.9% is equal to 10 times of T 50%. Right? So if T 50 is 45, that means I can say this will be 10 times of T 50. That means it is 10 times of 45 minutes. That means it is 450 minutes. Now the question is in hours, so divided by 60, we'll get 7.5 hours. That is option number D here. Okay, next question. Half-life of a reaction is found to be inversely proportional to fifth power of its initial concentration. Half-life is found to be inversely proportional to fifth power of its initial concentration. What is the order of the reaction? The general equation here is T half is proportional to half of n minus 1. So now we can equate this 5 and n minus 1. So n minus 1 is equal to 5. So n is equal to 6. So correct answer here will be option number B. Next, in a first order reaction, the concentration of the reactant is reduced to 12.5% in 1 hour. Concentration is reduced to 12.5% in 1 hour. When was it half completed? Okay, so now if you see, we have 100%, then we have 50%, then we have 25%, and then we have 12.5%. Okay, so now this whole thing is done in 1 hour. Okay, this whole thing is done in 60 minutes. Okay, that means this one will be 20, this one will be 20, and this one will be 20. So what is the half-life here? Half-life will be 20 minutes. That is option number A. Next, the rate constants K1 and K2 for two different reactions are given. Okay, respectively. The temperature at which K1 is equal to K2. Okay, so we need to find that particular temperature at which K1 and K2 are equal. So I will first write K1 is equal to K2. Okay, now what is the value of K1? 10 to the power of 16 into e to the power of minus 2000 by T. And here I will get 10 to the power of 15 into e to the power of minus 1000 by T. Right, now what happens? This is T10. And I'll take ln on both sides. So I'll get minus 2000 by T and this one minus 1000 by T. Take this 2000 to this side, I'll get 10 is equal to 1000 by T. Okay, 1 second. Okay, this one if I take, I'll get 16. Okay, fine, 1 second. I missed one step here. Okay, so first we'll take divide this one, 10 to the power of 15. If I divide on the LHS, we will have 10, right? Here I will have now 10 into e to the power of minus 2000 by T is equal to 1 into e to the power of minus 1000 by T, right? Now take ln on both sides. So I'll get ln of 10 minus 2000 by T is equal to minus 1000 by T. Now this one will shift here, so I'll get ln of 10 I can convert into 2.303 log of 10 is equal to 2000 minus 1000, that is 1000 by T. Okay, this value is 1, so I'll get T is equal to 1000 by 2.303. So correct answer here will be option number C. Next, the rate constant of a reaction is given by K is equal to Pz into e to the power of minus Ea by RT. Under standard notation, in order to speed up the reaction, which of the following factors has to be decreased? Okay, you need to increase K value. For that, which of the following factors should be decreased? That is the question. Okay, so now if I write this equation, K is equal to Pz into e to the power of Ea by RT. Okay, now see, to speed up the reaction, which of the factors should be decreased? Now if you decrease Z, if I decrease Z, then what will happen? Because it is directly proportional K and Z, so K will also decrease, right? K will also decrease, so we cannot have Z, so we can eliminate these two options. Now if you see this one, temperature, if you decrease temperature, what will happen? If I decrease temperature, Ea by RT, this factor will increase because denominator is decreasing, so fraction value will increase. So if this total value is increasing, then e to the power of that will also increase, and if this part will increase, then K will again decrease here. So that is why temperature is also not the correct answer. Now if I see Ea, if I decrease Ea, so I'll erase this one. Yeah, so if I see, if I decrease Ea, then what will happen? This fraction will also decrease. E to the power of that whole thing will decrease, then obviously K will increase. So correct answer here will be option number B. Okay. Now let us see the last question. For the reaction A to B, activation energy 50 kilojoule per mole and delta H is minus 20 kilojoule per mole. So we have EA is 50, okay, and delta H is minus 20. When a catalyst is added, the EA decreases by 10 kilojoule. So I can write EA in presence of catalyst is 50 minus 10, that is 40, decreases by 10 kilojoule. Then what is the EA for the backward reaction? Okay, fine, we can solve this question by doing a very good diagram here. See, so this is the reaction between A and B. Okay, now why I have taken B down? Because you can see this is an exothermic reaction, so product energy will be less than the reactant energy, right? So this value is how much? This is 20. Okay, and the activation energy of the forward reaction is this value. This value is 50, right? This is 50 and this is 20. Now what has happened when we use the catalyst? After using the catalyst, what has happened? This will become, the activation energy has decreased now. Okay, how much it has decreased? By 10 joules. Right, this decrease has become 10 joules. Now the total was 50 and the decrease has become 10. Then how much is this one now? Sorry. Then how much is this value? This value is 40. Right, now this is 40 and this is 20. So what is the activation energy for the backward reaction? For the backward reaction, if you see, this total is the activation energy. So this is 40, this is 20, total will be 60. So correct answer here will be option number A. Okay. So here students, that was the mock test 8 solutions. So I hope this was like complete revision and would have helped you to score, like to understand the concepts better. And if you are following this series, please do not forget to join our WhatsApp channel and subscribe the channel. See you soon in the next class. Okay, thank you, and remember your target 60 out of 60 in KCET Chemistry 2025 examination.